Welcome to GATEsolution YouTube channel. My name is Abhinav and I'm going to make your GATE preparation simple by building concept through questions, right? So let's start. In this question, you can see that this question comes in GATE 2017 2 marks SET-2. So in this question, the volume and temperature of air assumed to be an ideal gas in a closed vessel is 2.87 meter cube. Volume is given as 2.8 meter cube and temperature 300 Kelvin. The gauge pressure indicated by a manometer fitted by the wall to the vessel is 0.5 bar. If the gas constant of air is R 287 joule per kg Kelvin and the atmospheric pressure is 1 bar, the mass of air in kg of the vessel is, right? So the four options is given. We need to find out the correct option. Let's start this question. The solution, right? So let's first list it out. What are the data it is to be given? The first data it is to be given as the gauge pressure, and the gauge pressure it is to be defined as 0.5 bar. So let's convert it into in kilopascals. If it is to be defined that, it should be written as 50 kilopascal, right? Similarly, the gas constant, the value of R is defined as 287 joule per kg Kelvin. So I convert it into kilojoule, then it should be written as 0.287. You just simply divide by 1000 kg Kelvin, right? Now apply an ideal gas equation. So when we are talking about the ideal gas equation, it is to be written as PV is equals to MRT, right? But here P is a absolute. P is a absolute pressure, right? So we need to first convert the gauge pressure because it is given a gauge pressure. So we need to convert this gauge pressure into absolute pressure. So we know that if we want to convert gauge pressure into an absolute pressure, the equation should be written as P absolute is equals to P, that is the pressure of gauge, plus pressure of atmosphere, right? So in this question, gauge pressure is just to be given of 50 kilopascal plus atmospheric pressure. So that the value of atmospheric pressure in kilopascal, it is to be written as 101.325. So it means that your absolute pressure is equivalent to 151.325 kilopascal. So this is your absolute pressure. Now this absolute pressures you can apply it in this ideal gas equation, right? So in this question you need to calculate the mass, right? So I'm going to convert this in terms of, that is, mass is equals to PV upon RT, right? So the pressure you have already calculated, that is 151.325 into the volume, it is given as 2.87 meter cube, right? So the pascals unit is Newton per meter square. This is meter cube, right? Upon, that is, you already consider 2.87 into 300, that is the temperature is given in Kelvin. So in this ideal gas equation you have to take the temperature in Kelvin, right? So based on that you will get your answer should come is 5.04 kg. So the answer of this question is that is 5.00, right? You can also check the unit of this because they asked in kg. So your answer is also in kg, right? So that is 1.1. If I'm going to write mass, I'm going to write now the unit only. So this is kilopascal. So that is kilo into Newton per meter squared, right? This is meter cube. You have right. It is to be defined as a meter cube. R, the gas constant, is defined as a kilojoule per kg Kelvin. So we can write that is defined as a per kg and Kelvin it is to be written here, right? And temperature in Kelvin. Temperature in Kelvin. So I believe this K is to be cancelled out. This kilo and this kilo is also to be cancelled out. And this joule, meter square, Newton, meter cube is also to be cancelled out. So the unit comes under here is kilo kg, right? So the correct answer of this question is 5. Thank you so much, class.